Hello dear students, welcome to the second part of the video on graphical representation of motion. In this part we are going to discuss the area under the graph. So let's get started. In maths you have learnt area like area of a triangle, area of a rectangle and so on. So this is your triangle, this is rectangle, and what is this figure? Can you identify this? That's right, that is trapezium. So how do we calculate the formula of triangle, rectangle and trapezium? You all know the formula. So we are going to recapitulate that quickly before we get into graphs. So let's say this is your graph shown in this line, and you have to calculate the area under this graph, which is basically a triangle over here. There you need to apply the formula. If I call this base and this as height, the formula for area will be area is equals to half into base into height. Same way for rectangle, if I have to calculate the area, if I call this as L and if I call this as B, then the formula will be area A is equals to L into B. And for trapezium, I hope you all know the formula. So if the graph looks like this, so the area under this graph is actually going to be the area of the trapezium. So how do I calculate the area of the trapezium? If you remember the formula over here, if you call the two parallel sides, this is a parallel side. If I call this as A and if I call this upper one as B, and the distance between these two parallel sides as H, then the formula is the average of the two parallel sides, that is, write the formula A is equals to average of the two parallel sides, that is half A plus B. So A plus B by 2 means the average of A plus B multiplied by the height or the distance between the two parallel sides, and that I'll take as H. Sometimes the trapezium can also look like this, right, where the graph would actually be like this. From here the graph starts and then goes like this, let's say. Then how do we calculate the area of this trapezium? Well, in this case your parallel sides are this. If I call this parallel side, this one as A and this one as B, right, and we take this as height or the distance between the two parallel sides, again the formula remains the same. A is equals to half A plus B into H. So I hope you all know these basic formulas. If you know, let's get into the graphs. So here we have the question, and the question is to find the area under the velocity time graph. So this is the graph over here from A to B, and we have to find area under this graph, which basically means that we have to calculate this triangle. We have to calculate the area of this triangle. Okay, before I start solving this, I have something to discuss very important. When in maths you calculate the area, right, area is usually expressed in centimeter square, meter square or kilometer square, etc., depending on the dimension. If I take, let's say I take a triangle itself, if I take a triangle of dimension, let's say it is 6 centimeter and this is 4 centimeter, then you know the formula, this is half into 6 centimeter into 4 centimeter. So this is 12 centimeter square. So the unit basically will either be centimeter square, meter square, kilometer square. However, in physics, for this velocity time graph, to your surprise, the area will not be centimeter square or meter square. It is going to be, we'll explore right now what it is going to be. So remember, in case of a velocity time graph, when we calculate area, what do we get? Velocity into time. Remember, when we multiply velocity into time, we actually get displacement. And for a velocity time graph, when we are calculating area, this area is going to give us displacement of the object. It is going to get displacement of the object between 0 to 4 seconds. So in the 4 seconds, starting from the 0 to 4 seconds, what is the total distance or displacement of the object, and that can be calculated by calculating the area. So this is going to basically be half into base into height, because in this case the graph is in the shape of the graph actually encloses a triangle. So we have to apply the formula over here. So in this triangle, let us see exactly what is the base over here. The base B is your time, which is, if I take the final value as 4 and initial as 0, so this is 4 minus 0, so basically this length is equals to 4 seconds. And height, if I consider over here, the initial, this is your height. So height basically is in the velocity axis. So the value for point B is 40 meter per second, and for this point over here, this is 0. So what is the height over here? Height is basically this length, and that is 40 meter per second. So if I now put the value here, B is 4 second multiplied by the height, which is 40 meter per second. You can see here how nicely the two units S and S gets cancelled, and the answer is left in meters. So here we are getting the answer as, let us cancel this, 2 times 1 and 2, this is 80 meter. So area can also come in meters in a velocity time graph. So do not always think that area will come in meter square in graphs like this. The area can also be in meters. It depends on what is the unit. Since velocity is meter per second and time is in seconds, so when you multiply these two quantities, remember I told you, when I multiply meter per second and second, you can see second and second gets cancelled out, and we are getting the area in meters. So we got the answer of the first question. So the displacement of the object in first 4 seconds is 80 meter. Now let us see question number 6. Now before I give the solution, I recommend you to pause the video right here, do the solution, and then check the answer to verify. I hope you have done now. So we need to find the area under the velocity time graph basically, which means we have to calculate the displacement of the object here. So the graph goes from time t is equals to 0 to t is equals to 4 seconds. So what is the total displacement of the object? And for that we need to calculate the area that is enclosed by this graph along with the time axis. So remember, this shape represents a trapezium. So you can either take the trapezium and get the answer, or if you don't want to take the trapezium, you can actually divide this trapezium into a rectangle and a triangle and then add the two values. So I am going to show both the methods to calculate. If you don't know the formulas for trapezium, you can use the formula for triangle and rectangle and add the values. So let us start with the trapezium. So the formula for trapezium is area. Well, this area is going to give you displacement, so I write here displacement, which is equals to half a plus b into h. So here, which one is a? The two parallel sides. So the first parallel side is going to be here. This is your first parallel side, so I am calling it as a, and the second parallel side, this one is B, so I am calling it as B. So what is the length of A and B? B is 40 minus 0. Since the starting is 0, this is basically 40 meter per second minus 0, that is 40 meter per second. And what is A? A will be equals to 20 meter per second. So we got the value of A and B, and the height is the distance between these two parallel sides. So the distance between these two parallel sides will be basically in time 4 minus 0, that is 4 seconds. So now we can put the value over here. This is half. A is 20. I'll write the units also, and B is 40. So this is 20 meter per second plus 40 meter per second, and height over here is 4 seconds. So now I can cancel second and second, and this will be half into 60 into 4, and that is 120. The unit left over here is meter, so that is the answer. So in this case we get displacement, which we write as symbol S. So displacement S is equals to 120 meters in this particular case. Well, if you want to solve it by taking a rectangle and a triangle, you can also get the answer over here. So let me quickly solve that also. So if I take the rectangle, this will be like 20 meter per second and 4 seconds, because this is your length and this is your width. So this is going to be 20 meter per second multiplied by 4 seconds, that will give us 80 meter. And for triangle, your height is going to be like 40 and 20. So if I find the difference, this will be 40 minus 20, 40 meter per second minus 20 meter per second, and that is equals to 20 meter per second. That is the height of the triangle, and the base will remain as 4 seconds. This is half into base 4 seconds into height 20 meter per second. So if I again cancel second and second and calculate the value, this is 2 into 20, that will be 40 meter. And if I add the area of the rectangle and the triangle, you can see this is 80 plus 40, that is 120 meters. So you can use any of the method in the exam to find the area, and you can get the displacement of the object in a velocity time graph. So this was an easy question. Now this is even easier. So pause the video, find the answer, and let's verify. I hope you have got it now. So in this we can see it's a very simple graph. It's a line parallel to time axis. So the area under this graph will basically be the area of this. It seems to be a square. Let me call a square over here, but since the dimensions are not same, you'll find the values will be different. So the length of this part of the rectangle or square, whatever you may call it, this is 40 meter per second, and the length of this part will be basically 6 seconds. So if I have to find area, which also means we are finding displacement for a velocity time graph, displacement, and that is equals to area under the graph AB. Let us write the complete answer. Area under the graph AB, and that is equals to L into B. So the length, if it is 6 seconds, and the breadth is 40 meter per second. So from here we can cancel and get the answer as 240 meters. That is the displacement of the object in 6 seconds, right? This is, so you can see directly the object is moving with a constant velocity, right? The velocity is not changing for 6 seconds. So the answer will be basically 40 multiplied by 6, and that is 240 meter. So we have done question number 7. Now we have question number 8. This is going to be in 3 parts. We have part A, B and C. So this is the, like, whatever we have done, it's like the sum of all 3 questions. We will first find the area under the graph, find the acceleration of the object in the 0 to 2 seconds. Okay, we have to find acceleration. Well, we can find the acceleration and we can find the area as well. Acceleration will be from the previous video, if you remember. The acceleration can be calculated by finding the slope, and for this graph the slope will be a is equals to, please find the answer yourself. It is going to be this is going to be 20 meter per second square. And I think this question was supposed to find the area, so I'll change the question to find the area of the object in the 0 to 2 seconds. So how can we calculate the area over here? You can see here we have a triangle, so we can take the formula as area is equals to displacement. That is what we are trying to find over here, and that will be equals to half into base into height. Just identify what is base. So base is 2 seconds over here, and height is over here is 40 meter per second. So this is half into base as 2 seconds and height as 40 meter per second, and that gives us the answer as 40 meters. So here the object covers 40 meter in the 2 seconds. Now let us see the second part of the question. Again, this question, I think I did not edit this one, but this is to find the displacement. Find the displacement of the object in 2 to 8 seconds, means from here to here. When the object goes from B to C, what is the displacement of the object? Well, we are calculating between the point B and C, so we have to calculate the area under this graph, and that is going to be this region. So we have to find the area of this rectangle, and this is going to be very easy. If we see the dimensions over here, in time we have got 8 minus 2, and that will be 6 seconds. See the interval, right? This is 8, this is 2. So what is the difference? 6 seconds. Similarly, for the height of the this rectangle over here, this is 40 and this is 0. So basically the height is 40 meter per second. So you can now calculate the area or displacement. I'll write here displacement is equals to, in exam you are supposed to write like this: displacement is equals to area under VT graph, and that is equals to, I'll take the formula L into B, and length, let this be 6 seconds, and breadth be 40 meter per second, and that's again coming as 240 meter as S gets cancelled out. That's it. And if the question is asked like what is the displacement of the object, in 8 to 12 seconds, which will be like this one, because the graph between 8 to 12 seconds is C to D. So again we can calculate the area of this triangle and we can get the answer. This I'll leave up to you. I'll just write the answer over here directly. This is 40 half into 40 meter per second multiplied by 12 minus 8, and that will be 4 seconds. This is coming as 80 meter again. This is coming as 80 meter. Okay, this was the interesting question. Now, question number 8D is very interesting. It says to calculate the area displacement of the object from 0 to 12 seconds means from the starting point over here, from time t is equals to 0 from time to time t is equals to 12, the graph goes up, then horizontal, and then comes down, right? So what is the total displacement of the object? So in order to find this one, we can actually find the area of these three separate regions and we can add their values, and that calculation we have done already. If you remember, I'll just show the answers once again. The first answer was 40 meter and this was 240 and this is 80. So we can directly add the three values. So if I call this as 1, 2 and 3, so the displacement is going to be, this is method 1, I'll show another method as well. This is displacement is equals to area of region 1 plus 2 and 3. If we add all the areas, we get the same answer. So what is this? First one was 40 meter, the second is 240 meter, and the third is 80 meters, if you remember. So here we have got 240 plus 40 is 280 and 280 plus 80 is 360 meter. So this is the displacement of the object in 12 seconds. Now if you don't want to take out these three areas separately, well, you could have also taken the area of this trapezium and you can get the answer directly. So let's check if the answer can be obtained using this area. So this is a trapezium, so we need to identify the two parallel sides and the distance between them. So I am taking this BC as one parallel side, so this is going to be A, I am calling, and I am calling this as B. So what is the length of BC? Well, B corresponds to 2 and C corresponds to 8. So basically A is equals to 8 minus 2 and that is equals to 6, and well, this is time because we are calculating in the time axis. Similarly, B will be the entire length and that will be equals to 12 seconds. And what is the height or the distance between the two parallel sides? And that is basically 40 meter per second. So if we apply here and the area of the trapezium, we can get the answer. So I'll write here displacement is equals to area of the trapezium and that is equals to half A plus B into H. So half A over here we have taken as 6 seconds, B is 12 seconds, height is 40 meter per second. So this is half into 12 seconds into 40 meter per second. Let us cancel the seconds and seconds. This is basically 2 and this is 6. Okay, sorry, I did the addition wrong over here. This is 6 plus 12, 18. So this is going to basically 9. Okay, on cancellation 2 ones are 2 and 2 nines are 18. So basically this is 9 into 40 meter and we get the same answer as you can see, 360 meters. So we can calculate the area either in parts by finding the area of each part, or you can use the area of trapezium directly to get the answer. Now we have the final question of the day and one short question and then we'll do the final question. The question is very interesting and one of the best question of the day. The question is, when does the object changes its direction? So imagine there is a car moving on a straight road. Initially it is at rest. So in order the car to move, the car must accelerate, the driver must put on the accelerator. So the car goes from A to B with some acceleration and then moves from B to C with a constant velocity and then goes from C to D. It goes like this, and then after reaching a certain point it turns and returns in the same direction up to this point. So you have to identify which point A, B, C, D, E, F, which point is indicated over here, or the point where the object changes its direction. Well, if you have got the answer, then you can clap for yourself. The answer is D. This point basically denotes D. The object started at point A. From A to B it was accelerating. From B to C it was moving at constant velocity. From C to D it was deaccelerating, but at point D it also changed its direction and it is coming in the opposite direction over here. Why and how can we remember this? Just remember the concept over here. Wherever the graph crosses from first quadrant to fourth quadrant, wherever graph crosses from first quadrant to fourth quadrant, that point basically shows, this point shows change in direction. And how do I know this? Because these all are positive velocities. 0, 20, 40 means the object is going in forward direction, and when the object goes in the opposite direction it means that the velocity is going to be negative. Remember, velocity is a vector quantity and the graph for velocity time graph can be in both first quadrant and fourth quadrant. So here this point denotes change in direction of the object. Now let's get to the final question of the day. The question is, what is the net displacement of the object in 20 seconds? So the question is saying the object starts from here. This is point B and point C and D. So the car goes from point A to B, then C to D, and then it changes its direction and reaches to some point. Let's say this point P now called as somewhere E. While coming back, this point may be called as E, and finally let this point be called as F. Okay, so we have to calculate the displacement of the object in the 20 seconds. So well, you know, this is the initial point and this is the final point. So the displacement is going to be basically this much, right? This is your displacement. Okay, so how do we calculate this displacement, right? So here, instead of solving the area of each portion like this, we will actually calculate the area of this trapezium. So let us calculate what is the area of this one. So if I call this parallel side as A and if I call this as B, parallel side as B, the B is going to be 12 second, A is equals to 8 minus 2. I think we have done this part already. This is 6 seconds. Remember the calculation. I am calling this area 1. So area 1 is equals to half A plus B into H, and that is equals to half 6 seconds plus 12 seconds into height was 40 meter per second, and that is equals to 40 meter per second over here. That is half into 18 seconds multiplied by 40 meter per second, and on calculation we can get this as 360 meters. Okay, so this is the area of portion 1. Now let us calculate the area of the second part. So here again we can take this triangle over here directly, where I will take this as the base of the triangle and this as the height of the triangle. Okay, so the base over here is 12 and 20. So if we subtract over here, we get b as 8 seconds, and height over here interestingly will be minus 40, because starting from 0 to minus 40 the difference is of 40. So I have to take care of the sign. I'll not just take 40, I'll take minus 40. Very important, because velocity is a vector quantity, right? So we cannot just take 40. This is negative axis for the velocity, so I must take the height as minus 40 meter per second. So let's now calculate area 2. So area 2 will be equals to half into base into height, and that is half into 8 seconds into height as minus 40 meter per second. Well, you can see something coming up very unique. The answer is coming in negative. The area is coming negative, which is not usually in maths. Okay, so this is 40 into minus 40 into 4, that is minus 160 meters. So the area of the first graph over here is 360 meter, and the area of this graph is minus 160 meter. So if I have to find the total area, net area will be equals to, that is the displacement. Here net area will be the displacement of the object, and that is equals to 360 meter minus, we are just adding, basically we are adding the two area, but one is negative, so this is plus minus 160 meters, and that is going to be 200 meters. I hope you got the answer, right? So basically, while going from A to D, the object covers 360 meters and it returns almost 160 meters. So the displacement is 200 meters. So this is how we calculate the displacement of an object. I hope the concept of slope from the previous video and the area from this video is very much clear. So hope to see you in the other videos. In that video I will be discussing the other types of graph, that is displacement time graph, and we'll take up some numericals on different types of graphs there. So that's all for this video. Take care of yourself and happy learning.